Okay, cool. Right, so we've been looking at a few things. I just wanted to emphasize again, like I did last lesson, about how important it is to get the Google Classroom for lessons, because that's where everything starts from. So really important to jump in there and have a look and see what's going on. So yesterday's lesson about probability spinners, there were a few bits and pieces to have a go at there. There was actually nothing in Education Perfect at all yesterday. There was a little task that we'd built in Desmos. I know you had a really good go at that, Riley, so that's good. And then there was a bit about finishing off and designing a spinner and submitting that to me in the classroom to Mark. So that's all that yesterday's lesson was. So do just make sure you always go there, look for the lesson, because that's where all the details are. And just a reminder as well that there's quite often going to be videos and things like that in there for you to watch that will help you to do stuff. And this first video I put in probability still doesn't have many views at this stage. So yeah, that stuff's all in there to help you. The questions are the questions, but there's a load of other stuff that usually goes into the lesson before you get to the questions just to help you. Okay, on the on the chance experiment stuff that we did in Desmos. So yesterday, Riley, you were only joined by Kiana. That was the only other member of the class who did it. Okay, so yeah, we really just need to make sure that people are getting into the classroom and looking at the things they need to be doing. All right, so today we're going to look at tree diagrams, which is a way, again, of getting some probabilities of some more complicated looking things. Have you seen this before, Riley? You might have. Okay, it might come back to you a little bit. But it is a more advanced way of being able to work out some more complicated probabilities. Again, when we've got things where we've got combined events happening, things that may be and maybe not affecting each other. So we'll look at a little example to start off with. And this is the way we kind of draw it out. All right, so I'm going to break it up into little bits, so we'll see how we draw it out. So we've got Neil here, and he wins a dice game with probability of 2/5. And he's going to play 2 games. And the first thing is we're going to have to be happy about how to draw out the tree diagrams to be able to use them to get probabilities. So the first thing we do, we think about, he starts here. All right, before he's played a game, he starts here. And he can either go down this branch to win the first game, or he can go down this branch where he's lost the first game. Okay, so that's the first bit. He starts out here, and we just do a little branch and say, well, he's either won the first game, or maybe he lost the first game. The 2/5 we write on this branch because the question told us the probability that he wins a game is 2/5. So we write that on the branch. Why do we write 3/5 on the other branch? Can you? Yeah, because if 2 out of 5 times he wins, 3 out of 5 times he loses. Yeah, and as you said, Riley, 2 plus the 3 gives you the 5. Okay, so that's game 1. Now we have to think about game 2, and in game 2, he either won the first game and ended up here, or he lost the first game and ended up here. So we have to draw out some new branches going from there. So if he got to win, what could happen next? Well, he could win or lose. If he got to lose, what could happen next? Well, he could win or lose the second game. So we get something that looks like that. Okay, so he could win the second game after he's won the first game, or he could lose the second game after he's won the first game. If he lost the first game, he could win the second one, but he could also lose the second one. And I've still put 2/5 here because I know the probability that he wins a dice game is 2/5. What goes on the lose bit here? What fraction would I write there? 3/5 again, yeah, just the same. Yeah, just the same, isn't it? So just as we had before, that's going to be 3/5. 3 out of the 5 times, he's going to lose. What goes here on the win after he's lost the first time? Can you see? What's the chance that he wins the second game? So it's telling us right. Yeah, it's still 2/5, absolutely, Riley, because it's just saying the probability he wins a game is 2/5. So it doesn't matter whether he won or lost. The probability he's going to win the next one is 2/5, and the probability he loses the next one is, to go here, 3/5. Okay, that is our tree diagram built. All right, we start by thinking about where he starts, he either wins or he loses. We write down the probabilities that he wins or he loses, and these two have to add up to 1. The 2/5 and the 3/5 make 5/5. It's 1. The 2 and the 3, as you said, Riley, makes 5. And then we think after he's won the first game, where could he go? Well, he could go to win the second game or lose the second game, and we write the probabilities on of that happening again. 2/5 he won, 3/5 he lost, just like before. And if he lost the first game, well, it's still 2/5 he wins the second game, and it's 3/5 he loses the second game. So we just write a little bit more after that part of the screen. So let me just go next. So what we write down here is, what's the probability of me going all the way down here, going win and then win? And what we do is we multiply the probabilities. 2/5 and 2/5. We multiply along the branch that we go. All right, so 2/5 times 2/5 is what we have to do. Now, if you remember doing the multiplying fractions is quite easy. Nothing cancels here, nothing simplifies, so we just multiply across the top and multiply across the bottom. Happy that's 4/25? Yep. Okay with that being 4/25? So 4/25 is the probability that he wins both games. We then fill in the next bit, and I've started off the first bit. He took 2/5 to get to win. What do I write on the next bit? 2/5 times what? 3/5, yeah, because it was 3/5 then, wasn't it, for the lose? And then I do my timesing. That's going to be 6/25. Is that okay? So 2 times the 3 across the top, 5 times the 5 across the bottom. That's the probability then that he is going to have won the first game but lost the second game. The next one, if we look at that, goes similarly. We've got 3/5 to start with, and that bit's written in there for us. 3/5 to lose, 2/5 to win. So we have our 2/5 again, and 3/5 times 2/5, that is still 6/25, isn't it? 3 times the 2, 6, 5 times the 5, 25. So the probability of him losing then winning is the same as him winning then losing. All right, doesn't matter which way round it has, it's going to be 6 out of 25. If we look at the lose-lose bit across the bottom, we've got 3/5 and then another 3/5 to times together. So 3/5 and then another 3/5 to do on there. So let me just write that one in. What's that going to give us at the end as the probability? Times them together. 9 over 25, Riley, yeah. 3 3s are 9, 5 5s are 25. That is a complete tree diagram now, and it helps us to answer a lot of questions. Okay, now there are 4 different things that could happen. We could have gone win, then win. We could have done win, then lose, and sometimes you write these sort of shorthand bits on the end, lose and win and lose and lose. But the probability is not a quarter of each, is it? I know there are 4 of them, but it's not probability of a quarter ending up at each point, because the chance of him winning a game is not a half. So we have to think about how that works out. So we multiply along, and that gives us these chances. Actually, we can see from all of this which thing's most likely to happen if he plays the 2 games. Can you see from the probabilities at the end which bit's most likely to happen? Losers. Yeah, that's the most likely one, isn't it? That he loses twice in a row, because that one's 9/25. It's bigger than the others. All right. The least likely thing is that he wins both. Okay. That's only 4/25. All right. In my box at the bottom, I've got a couple of questions. What's the probability he wins both games? All right. Writing P wins both like that just means what's the probability. It's a short way of writing it. All right. Maths way. Well, we can see probability he wins is just 4/25, yeah? That's it. All right, we can see that from our diagram. If we look at our next question, what's the probability he loses both? Well, again, we can read it off our diagram, can't we? We've just got it there. Our diagram tells us 9/25. Without drawing the diagram, though, those questions can be quite difficult to answer. All right, the diagram really helps. So just to go back over how you start the diagram off again, right? Think about where he starts. He will either win or lose that first game. Write down the probability on the branches of the tree. If that was 2/5, this must be the other part of it. It must be the 3/5. And then after the first game, he's going to win or lose after he already won. He's going to win or lose after he already lost. Fill in the probabilities again on the branches, and then times along the branches to get what the probability is of ending up at each one of these 4 points. So for this one, 3/5 times 2/5, 6/25. Okay, diagram does the work for you, just like on the sample spaces, the diagram does the work. Could we ask any other questions from that diagram, do you think? Can you think of any other questions we could have asked ourselves? That's good. That is a good question. Right? Okay. The probability of winning one and losing one. I like that because there are both of these two here work, don't they? Yeah. We could have either won and then lost or lost and then won. Both of them have got probability 6/25. So how many out of 25 is it going to be to end up in that place that you won one of them? 6/25 times you'll win the first, lose the second. 6/25 times you'll lose the first, win the second. How many out of 25 have you won one and lost one? Can you see? We just need to add them together. What's 6/25 add 6/25? How many 25ths? 12/25. Yeah, absolutely right. 12/25. So the chance of him winning one and losing one is 12/25. The chance of him winning both is 4/25. The chance of him losing both is 9/25. Okay, add those ones together in the middle because they both show me that he won one. That's what you said, wasn't it? Win one, lose one, Riley. Yeah, it's a good question. That's a nice question, that one. And the tree diagram makes that possible. But if you just read the words at the top of the question, I think you're really going to struggle. I'd struggle to figure out what that's going to be. If it just says probability he wins a dice game is 2/5, he plays 2 games, what's the probability he wins one and loses one? We're not really going to get to 12/25 very easily without the diagram, are we? Okay, the diagram really does it. Right, let's have another one then, just to make sure we got this. So we have got some discs in a bag. All right, there are 6 red, 3 white. We draw a disc out, we take a disc out of the bag, and then we put it back in and take another disc, and we record what colour discs we get. All right, so we've started off the tree here. Some of the tree is filled in for us. What's going to go? What's missing here? What should I be writing at this point? You see, I might not be able to see where I was whizzing about there, but under where it says white, there's a gap. What should go there? Red, because it's either white or red, isn't it? Yeah? And I know I can fill that in on the other ones as well, can't I? So it was either white or red. And what's going to go here? White or red, isn't it? Yeah. So we're just showing the things that could happen, white or red. Now, 1 in 3 times we will get a white disc the first time. You see why that is? Because there are 9 discs and 3 of them are white. 3 out of 9. You can divide the top by 3 and the bottom by 3, you get 1/3. Yeah? 1 in 3 times we will get a white. What goes on the red branch then? What's the probability? So that's 2 in 3 times. Yeah, 1 in 3 times he gets a white, 2 in 3 times he gets a red. And we can copy that through. 2/3. Yeah. 1/3. 2/3. Right, now let's write down some of these things. So that's W and then W. That's W and then R. That's R and then W. And this is R and R. Okay, let's write on our probabilities then. So This one, going along this branch, will have done the third along to white. Bring up my pointer because it's a little bit easier to see. So I've gone there to there. So there's a third. And then from here to there, another third. So a third times a third. Okay, so let's just do that. So we've got a third times a third for that one. Third times a third is times across the top, times across the bottom, a ninth. Yep. Next one, we do white first. Well, that was a third. And then red. 1/3 times 2/3. Well, that's just 2 ninths then, isn't it? 1 times 2 is 2. 3 times 3 is 9. Next one, 2/3 for the red and 1/3 then for the white. So 2 ninths, yep, again, good job, 2 ninths. And then the bottom one is 2/3 both times, isn't it? 2/3 for the red first. 2/3 for the red second. Yep, good job. Right, 4 ninths. Okay, oops, 4 ninths. Right, let's see what questions it's asking us. So once we've filled in the diagram, then we think about how we use the question. Probability both discs are white. What's that from there? White and then white. 1/9. Yep, okay. So we've got to here, haven't we? Whoops, no, that's not there. 1/9. All right, so 1/9 that they are both white. What's the chance that they're both red? 4 ninths. Yep, there is 4 ninths. And they are the same colour. Right, what does that mean? So they could both be white or they could both be red. We'll allow either. So what's the probability we ended up somewhere where they're the same colour? Can you see what we'd have to do? So which bit? Sorry, you're going to say something? No? Okay. Which bit's going to work? Which bits show me they are the same colour? This bit and this bit. Yeah. So we just add them together. And that will tell me the chance that I'm at one of those. 1/9 and 4 ninths. How many ninths? 5 ninths. That's it. Yep, 5 ninths. So actually, we can see from that, it's more likely when we do this that we get both the same colour at the end than we get them different colours. Because 5 ninths is bigger than a half, isn't it? 5/10 would be a half. 5 ninths is bigger than a half. Half of 9 is 4.5. So it's a bit more than half. A bit more than half the time we'd get two the same colour. Interesting. We might not have thought that to start with. Yeah. We might think, well, it's going to be equally likely we'll get both the same colour and both different colours. But actually it comes out here because of the number of discs we've got in the bag. We've got a better chance, just slightly better chance than evens, of getting both discs the same colour. All right. How do you feel about drawing those kind of diagrams and using them? Seem okay? Yeah. How are you feeling, Tarek? You okay? Yeah. Okay. Let's have a little bit of a play together then. I know there's not so many of us here today, but let's just have a go at these ones and we'll see how we get on together with them. All right. So there's going to be some stuff to do and have a go. Don't worry about holding your answers up for the minute. We'll just deal with that. That is incredibly loud on my end. Just going to turn that down. That's a little better. Right, okay. So, our first question, see if we can do this, have a go together. All right, I'll give you a little time and then we'll see how we've got on. You can start on 10 if you want. Remember, we get 1 point for a correct answer, lose a point for a wrong answer. Write them down, what the answer is going to be. So we're going to start off with our first one. So the question here is what fraction should go in the blue box. So there we've got a bag with red and blue counters in it. And we're marking on our tree diagram from 2 picks, do we get red or do we get blue? Okay, you had a go. Who wants to offer what they think goes where the blue box is? What? 2/5, and you are spot on. Okay, Was that all right, Tarek? 2/5? Yep, same as before. All right, same diagram. The next one. What goes in the red box? What would go where the red box is? So that's showing we get a blue the second time. And after we took the first one out, we put it back in to take another one out. So what goes there? Both got answers? Yep. What'd you get, Tarek? 2/5 again? Yeah, it's just the same, isn't it? That's the fraction that goes in the red box. Good job. Right, okay. One more on that diagram. What goes in the green box? 3/5. Both in agreement, 3/5. Yeah, because it's the red one. 3/5. Okay, right. So that was just getting started. That was just about making sure you can write the fractions in the right place. Let's have a look at this next one then. All right. Oh, sorry, there wasn't one of these ones. It's the purple box. I thought I only had 3 of those ones, but I put it next to it. 2/5. 2/5, because it's the blue again, isn't it? 2 out of 5 times we get the purple one. Right, okay, this is one which does move on from that. We've done all the coloured boxes there now. Can't be any more. Right, but this is the complete tree diagram now with all those probabilities we've just said for those other boxes filled in. Can you work out then, what's the probability that you end up with 2 blue buttons? Think about where that is. What's the probability you've ended up with 2 blue buttons? Which fractions you multiply together? You're absolutely right. We've got to multiply, let me bring my laser pointer up, the 2/5 times the 2/5, isn't it? Go along that branch, 2/5 times 2/5, 4 out of 25. Okay, 2 times 2, 5 times 5. Okay, let's go. So let's try the next one. It's the same one. What's the probability of 2 red ones? All right, try not to call this one out. We'll see. Just tell me when you're both ready. 2 red ones. Red and red. So we're going across the top and across the top again. So just let me know when you've got an answer. That's good. How are we doing, Tarek? Can you see what you're going to do on that one? So if we write on, yeah. So we're going to have to do 3/5 times 3/5. 3 times the 3, 5 times the 5. What's our answer? Who's going to go for it? 9/25. Good job. Okay, 9/25. 3 times 3 on the top, 5 times 5 on the bottom. Good. Excellent. Right. Different bag. 3 yellows in there, 4 greens. What's the probability we get 2 greens? Just again, tell me when you've got an answer. You've got an answer? How are we doing? So we got 4 sevenths on this one and 4 sevenths. So we need to do a 4 times 4 and a 7 times 7. 16 over 49. Yep, 16 over 49. 2 green ones, 16 over 49. Next one up. Right, this is one where you're going to have to think about it a little bit more. 2 different coloured buttons. So let me just give you a bit of hand if you're not sure. 2 different coloured buttons. So we could... brought the answer up. That sort of spoiled it. Right, if you didn't see that. I'm supposed to be getting my pen back. That was what I wanted. Sometimes these things are a bit trigger happy. So we could either go red, then blue, or blue, then red. So we've got to multiply along both of those. Yeah, so we've got to look at our 3/5 and a 2/5, or it could have gone the other way around. So 3/5 and a 2/5, or 2/5 and then a 3/5. So we do the first one, the 3/5 and the 2/5. We times those ones together. We're going to get 3 times 2 is 6. 5 times 5 is 25. And on the bottom one, 2 times 3 on the top is 6. 5 times 5 is 25. So what's my answer? I've got to add them together. If I've got 6 25ths and another 6 25ths, how many 25ths have I got? 12. It did say that, didn't it? I did give that one away a little bit. 12 25ths, okay? That's the probability you've got 2 different coloured ones, all right? The R and the B, and then the B and the R both work. Add them together. 6 25ths had 6 25ths. Okay. So here we've got a spinner. Okay, the way this is marked up for us, make sure I don't click to the next slide. So we're saying here we got a 5 the first time. Here we got one of the numbers from 1 to 4. Here we got a 5 the second time. Here we got a number 1 to 4. All right, and it's 1 out of 5 chance we get a 5 because there's only one 5 on there. 4 out of 5 chances we get something else. What's the probability we get 2 5s if we spin it twice? Ooh, Riley, have a think. Yeah, there's a very common error just cropped in there. Can you see what you've done? You've got this for the first one, yeah? And then you've got this for the second one. Times them together, times the top numbers together. It's 1, isn't it? Yeah? You'd be amazed how many times people say that's 2. They start doing it. We're times in the top and we're times in the bottom, aren't we? 1 out of 25. Okay. Let's try them again. Right. Can you figure out what's the probability you've got the top score that's possible when you add the numbers together? All right. So we've spun the thing twice. What's the probability we've got the top score when we add the numbers together? So we'll take the score we got on the first spin and add that to the score we got on the second spin. That should be quite an easy question, because what does it mean we've got if we've got the top score? It means we've got 10, and we were at the 5 and the 5 again, aren't we? Yeah, we already know that's 1 out of 25. Yeah, 5 and the 5 again. We already know that's 1 out of 25. So sometimes the questions can ask you something else that's not actually on your diagram, but you can figure out how to use your diagram to work it out. Okay, let's have this one. What's the probability here of 2 yellow buttons? What's the probability of 2 yellow buttons? Just let me know when you've got an answer. You've got an answer, Riley. Excellent. Let me know when you're there, Tarek. So let's just recap what we've got on this one. We have, if I bring my pen back, my pen is on, that's okay then. So we've got the 3 7ths because we've gone to yellow the first time, and then 3 7ths because we've gone to yellow the second time. 3 7ths times 3 7ths, 3 times 3, and 7 times 7, 9 out of 49. Okay, on that one. Right, here's a different one altogether. Now, this is the first one we've seen, guys, where we're looking at 2 different things. So Jack here is doing an English test and he's doing a maths test. And we've got the P and the F stand for whether he passes or fails. So on the English test, there's a 4 in 5 chance that he passes and a 1 in 5 chance that he fails. But then the second part of the tree shows us what happens on his maths test. On his maths test, there's a 7 in 10 chance he passes, but a 3 in 10 chance that he fails. So what's the probability he passes both? So he needs to go P and then P. He needs to end up here. So again, let me know when you've got an answer. P and then P. So you've got this, and then you've got this. What's that going to give us? You've got an answer, Riley? Yeah. So what have we got? We're going to have to do 4 times 7 across the top and 5 times 10 across the bottom. But do you spot something once you've done both of those? If I do 4 times 7, I get 28. And if I do 5 times 10, I get 50. Do you spot something here, though, that we maybe should do with that fraction? Can we simplify it? And what does it simplify to? Is there a num? Yeah, you're right. 2 will go into both of those numbers, won't it? 28 can be divided by 2 to get 14. 50 can be divided by 2 to get 25. So we should look out as well to see if we can do any simplifying. We always want to give our answer as simple as possible. 14 out of 25 is his chance of passing both tests. That's a bit better than a half. 12.5 out of 25 would be a half. So it's a bit better than a half chance of passing both. I think we might do this one and then we'll call it a day for today. What's the probability of 2 yellow shapes? Hopefully a nice quick one. Do we have an answer? Yep. What have you got, Riley? 1 over 16, because on this one we've got to do the yellow. So the first time yellow is a quarter. The second time yellow is a quarter as well. Quarter times a quarter. It's going to give us 1 out of 16. Okay, guys. Thanks very much for turning up to today's lesson. We will check back in another time. Hopefully that's all okay. Just need to, get used to a little bit to using those diagrams and filling in. There's no other work to do from today's lesson. That was it. It was just about having a bit of a play, looking at how we fill in tree diagrams and we use them. So nothing else you need to do. Great job for turning up today. Any questions, or is everyone all right? If you're okay, then I'll say bye and see you next time.